Have you ever heard someone tell you when you're sick, don't worry, you'll never have the same cold again, or that once you've had chickenpox, you won't get them again? While there are exceptions to the rule, this is all thanks to your immune system. Our immune system is our own personal line of defense to stop and kill any invading pathogens in our body. Pathogens are microorganisms that cause us to become sick or to have an infection. The main pathogens we are exposed to are bacteria, viruses, fungi, and protozoa. We have three main lines of defense. Haven't you always thought that our skin was designed to keep our insides on the inside? While this is one of the skin's functions, it is actually designed to keep pathogens out. Pathogens cannot enter our body through our skin unless it becomes damaged. This can occur when we fall and graze our skin or cut our skin. What about our nose? While it is not covered in skin, it is still protected. Areas like the nose are covered inside with mucous membranes. Think of it like inside our nose is covered in thick honey. The pathogens become trapped in the mucus and cannot enter our bodies. The skin and mucous membranes make up the mechanical barrier. This is one of three barriers that make up the first line of defense. The second barrier is the chemical barrier. This protects your eyes and mouth. Tears and fluids on your eyes are not just to show you are sad, but also to wash away invading materials. This is why when you get something in your eye, it waters. Your body also uses saliva and sweat as chemical barriers. The final barrier is our body's reflexes. This is when we cough, sneeze, or swallow. Coughing and sneezing expels mucus out of the body. Swallowing also does this by passing it through the digestive system. If the pathogen enters our body, it starts to multiply. The pathogen continues to multiply without the body realizing until the pathogen builds up a big enough army to cause harm. The body then fights back. This is the second line of defense. The second line of defense in our body's army is groups of cells that in turn come to take part in the battle. Firstly, phagocytes. This cell's job is to seek and destroy, or destroy on command. They do this by eating the pathogen and breaking down the pathogen with potent enzymes. These enzymes speed up the biological reaction between the phagocyte and pathogen, allowing the pathogen to be ingested and digested. To help blood vessels release water into the infected sites, this is what we know as swelling. Phagocytes can be motile or fixed, simply meaning some travel around the body while some stay in fixed areas. Fever. As the phagocyte destroys the pathogens, they release a substance called progene. This substance triggers the fever, telling the brain to reset the body's temperature. This process slows down the speed at which pathogens multiply. Next are the protective proteins, the inferions that are emitted by infected cells, and the complement proteins that are inactive in the bloodstream until they encounter bacteria. Then, like little boxes, they punch the cell until they form holes big enough for fluid and electrolytes to enter the cell, causing the cell to explode and die. Killer cells are the ninjas of the immune system. These lymphocytes, which are white blood cells, take on cancerous and tumour cells. Cancerous and tumour cells are missing key markers on the outside of their shell that all other healthy cells have. Only the natural killer cells can detect this. The first and second line of defense forms the non-specific or innate immunity. However, to answer our question, we need to look at the specific immunity stage. This involves the T cells and B cells. Both originate from the bone marrow, but mature and behave differently. Think of it as a hierarchy in a top-secret attack force. We will call it the Top Secret Antigen Task Force, or the TSATF for short. Firstly, T cells. These cells are in charge and are the agents of the TSATF. T cells mature in the thymus organ. Once matured, they start to fulfill their role, which is dependent on the type of T cell they become. Killer T cells release toxins that kill agents and instruct macrophages to become active and start killing. Helper T cells decide what to do next. They can release a substance called cytotoxic that activates T cells or can trigger B cells to produce antibodies and activate macrophages. They can also decide to stop the fight. Suppressor T cells turn off the immune system response once the pathogen is overpowered and defeated. Once the mission is complete, we are left with some memory T cells. These memory cells keep a file on that exact pathogen so that if it ever returns, it can be killed quickly, stopping us from becoming sick. Now, B cells. B cells are like the office workers at TSATF. They stay in the spleen and lymph nodes, the sectors of the office. The B cells wait for instruction. T cells instruct B cells whether to turn into plasma cells and start producing antibodies or not. When activated, they receive a file on the intruder. They then design and produce specific antibodies that will track down the intruder and alert T cells and other cells in the second line of defense to destroy. Memory B cells are created and stored in the lymph nodes, and if there is another attack from the same pathogen, the B cell will instantly turn into a plasma cell and start making antibodies. These memory cells are the main reason that we do not become sick when exposed to the same bacteria, virus, fungi, or protozoa for the second time. Linking back to our chickenpox example, once our immune system has formed memory cells for the chickenpox, any second or subsequent exposure is dealt with swiftly before it can cause harm to our body.